Alright, let's get this done. It's really cold outside, so if you have nothing better to do, maybe you want to watch this video for a little bit. Like I said, nothing better to do. Cold day like this, stay home, make some bread, some jerk chicken, season your iron cast, little things. Let's see. Boys and girls, days and money. So this is the amount of money here depends on days. So again, I like that. Right, the total amount of money depends on the number of days. So I know this is going to be my Y, this is going to be my X, right? So if it's proportional, and we can see that it might be, okay, so I don't want to assume, because we had a problem where in class where it was 0, 0, but then it ended up being not proportional. So 0, 0, what's a constant proportionality here? Well, remember, constant proportionality, now if you label this X, you label this Y, there's no guessing. So constant proportionality, right? The number that you multiply this, right, to get to that, right? So if you divide Y over X, pick any of the Y values, 4 and 60, 3 and 45, 2 and 30, doesn't matter. So let's pick this one. If you do Y over X, you get 60 over 4, which means K equals 15. Well, let's try it out. So it says times 15, that works, times 15, that works, times 15, that works, times 15, that works. Now that's, if I put it on the graph, right, it'd be 1 and 15, 2 and 30, right? You'll see that's proportional. Constant proportionality is the same. What is the constant proportionality? K equals 15. All right. So which of these is the input or the quantity that affects the other, and which is the output, the quantity that affects, which is the output, the quantity that changes based on the input? Well, the input is your X, right? Your output is your Y, and now that you know who they are, you can write that days, X or days, and Y is your money, right? So the total amount of money depends on the number of days that you work, and that hopefully makes sense. Right, move on. Write the equation. Because it's proportional, right? Your equation is going to be in this format: y equals kx, and it's just going to be y. And we found out what k was. K was 15. There we go. Y equals 15. So that the total, the output, right? The money will depend on the number of days. So y equals, and let's say you worked 6 days. Well, it's $15 times 6. Y equals 90. So the total that you earn will be $90. Okay. So write the equation in words. Again, we just did that. So total amount of money, is equal to $15 multiplied by the number of days. Okay. Well, check your work with 2 ordered pairs. Well, let me go back here for a second. So the ordered pairs, or the coordinates that we had, let's pick 2. Well, we have 4 and 60, 3 and 45, 2 and 30. It doesn't matter. So let's just pick the first 2. So let's pick 1 and 15. We can even pick 0, 0. So to make your life even easier, you can pick 0, 0. So I'm going to pick the first 3. All right, and I know I didn't ask for the first 3. So the ordered pairs that I have, and again, we had a table. We had 0, 0, 1, 15, 2 and 30. So 0, 0, my first point, 1 and 15, my second point, 2 and 30. You can pick any 2 points. I mean, you could have gone and pick 10 and 150, right? It just didn't matter which points you had. So here's the graph of that line. So right, the line y equals 15x is gonna be a line that looks like this, goes through the origin, right? Straight line. And any point on this line, doesn't matter what point, any point, as long as on the line, will make the equation true. So here was my equation, y equals 15x. Let's substitute. Let's try 0, 0. So with 0, 0, y equals 0. 15 times 0, and you get 0 equals 0. Look at that. The equation is true. Let's try another one. Y equals 15x, and let's pick 1 and 15. So let's use 1 and 15. So x is 1, 15 is y, so y is 15. X is 1. And again, the expression on the left equals the expression on the right. So try 2 and 30. Again, y equals 15x. Now let's try 2 and 30. Y is 30. 15 times 2. Look at that. So it doesn't matter. Okay, whatever 2 points you picked, that'll be fine. Suppose x varies directly with y direct. I can't read. Y varies directly with x. When x equals 8, and let's create a x equals. So when y equals 8, and let me create another box over here. Nothing stops you from making a box. When y equals 8, x equals 5. So they're giving us that, right? So they're giving us that. So they're giving us that when x is 5, y equals 8. So we know that. So let's complete the table because it's asking us this missing value. Okay, so well, I apologize because I didn't need to create a box. There's a 5. I could put an 8. We can use the constant proportionality, right? So if you have, maybe it's easier for some of you to look at it like this. 0, 0, 1 we don't know. We know that 5 is 8, 7 we don't know, 15 we don't know, and 20 also we don't know. So we're missing a few numbers here. So we can find constant proportionality. So k equals y over x, and the only one that I can use is this because I have both x and y. So the y is 8. And the x is 5. So let's try it out. So when x is 5, I get 8. Well, let's see if that's true. If you multiply 5 times 8 over 5, do you get 8? Well, yeah, because if you simplify, look at that, you get 8. So 5 to 8, constant proportionality. So let me change colors here. It's times 5 over 8. So all you have to do is every single value is multiply times 5 over 8. So when x equals 1, right, and if that's the constant proportionality and the unit rate, right, is when x equals 1, you can write over here, all right, like that, 5 over 8. When x equals 7, well, 7 times 5 over 8, and you can leave it as a fraction. I'm going to leave it at 35 over 8. When x equals 15, okay, 15 times 5 over 8, it's going to be 75 over 8. We can change the mixed number, but it's okay. And when x equals 20, right, so we get 20 times 5 over 8, and we can write 100 over 8. Right, so there is my answer here. 3 based on the graph shows how much the baby grew in centimeters after a certain month. Okay, so again, the graph right away tells you who the y and the x is. So again, you can come up with a sentence right away. The baby grows, let me write his height, I guess, right? Centimeters. The height of the baby in centimeters depends on the months, right? That makes sense, right? So the first question you ask yourself is, do you see a constant proportionality? Yes. The answer is yes. Goes through the origin. Goes through the origin, right? Straight line. Y, again, you can write that goes through the origin. I don't want to answer. I'm going to answer the y part by doing the second part. So one method is to check if there's a constant proportionality. Well, let's look at some points over here. Right, so first of all, on your graph, maybe right away you want to go and just, even though it didn't ask you, when you a little dot there, and understand that this 0.1/30, this is your unit rate, right? And we can write it as 30 centimeters in 1 month. That's what the baby does every month, right? That's your unit rate. It goes up. He grows by 30 centimeters. And this 30 is your constant of proportionality. Right, so if you have a table over here, right, and let's get some numbers. Here's my x, here's my y, right? X represents the month, and here's the height of the baby. 0, 0, then we have the 0.130, and we have the 0.260, then we have the 0.390, and so forth, right? So 4 would be 120, 5 would be 130. Now, notice that with each of these is times 30, times 30, times 30, times 30, right? The ratio, right? So if you take the ratio, k, right, of y over x, so if you take any of these points, doesn't matter which one, any of these points, and you divide 130, the output, over the input, right, the y value over the x value. So let's try 130 over 5. Sorry, 150. 150 over 5. So if you divided 150 over 5, you get 30? Yes, you do. If you take this point over here and you did 120 over 4, do you get 30? Yes, you do. If you take this one, do you get 30? Yes, you do, etc., etc. So it doesn't matter which one, whichever point you take on this line, the constant proportionality is the same. So I guess we can say that that's the answer to the second one. I asked myself, if there's a constant proportionality, in other words, the unit rate, how can I find this in the most efficient way? Well, the most efficient way was what we did a couple seconds ago, right? Look at the graph, find where x equals 1, this value right here, right? If it's proportional, your unit rate is this, and the y value, right, when x equals 1. So when 1 comma whatever the y value is. Okay, so that would be one method. A second method would be to look at your outputs or inputs, and remember that after 1 unit of input, how many outputs increased by? In this case, after every 1 month, the baby increased 30 centimeters. Okay, therefore the baby grew 30 centimeters for every 1 month. Okay, so this is the number of months, baby's 30, 2 months, baby 60, and so on. The constant proportionality in this case is 30, right? Alright, so the equation is proportional, so it will be in the format y equals kx, right? Y equals the constant proportionality times x. So what am I multiplying x by, right? What is this number that I'm multiplying x by to get to y? And we just found that out. It's 30. Right, so it's 30x. The equation in words states that the height of the baby, which is y, the height of the baby, is equal to 30 times the number of months. Is your answer reasonable? Try plugging in some number and comparing it to the graph. Yeah. So you have the equation y equals 30x. Right, so I don't know if you want to play around. So let's say, hey, after 1 month, y equals 30 times 1, y equals 30. Right, so after 1 month, he grows 30. After 2 months, so again, you can use the equation. Right, now let's try something else. Let's try 7 months. Right, so let's make another box here. How tall is the baby? So after 7 months, it'd be y equals 30, and then x represents the number of months times 7. The baby will be 210 centimeters. Wait a second. Why is this baby growing so fast? Hang on a second. Did I get this correct? 1 month, 30 centimeters. 2 months, 60 centimeters. 3 months, 90 centimeters. Wait a second. This baby's super tall. Well, I wouldn't go too far with this because after 10 months, the baby will be 3 meters tall. So maybe, okay, so I guess I'm going to talk about here. So if your equation is y equals 30x, right? And I don't know how far this can go, but let's play to number 10 months. If that's constant, y equals 30 times 10, y equals 300 centimeters. Guys, want to think about that for a second? That means the baby at 10 months is 3 meters tall. So, is my equation is reasonable for maybe, I don't even know if this equation is reasonable. Are the numbers? 1 month, he's at 30 centimeters. Okay, that I can do that. It's the size of a ruler. 2 months, he's doubled. No. So, all right. So maybe this what do you call this scenario is not super realistic. Okay. I mean, just for you to have a reference, my height in centimeters, I'm 178 centimeters. Okay. So maybe it would be a little bit taller than me by 10 months. Ooh. Am I getting? Yeah. Yeah. So maybe the first. Oh my God. I didn't even notice this. At 3 months, the baby's 90 centimeters. All right. Well, anyways. 4 centimeters. Sorry. Question 4. The New York Giants water boy is filling up the tank. The table below shows the amount of waters. So in the tank after amount of minutes. Okay, so that makes sense, right? So again, this is my x, this is my y. Now because one came first, and the second came, the y came second. So if you make that statement, the amount of water in the tank, I'm gonna write that, depends on the number of minutes. Right? That makes sense. Okay, so at 0 minutes, there's 0 water. After 1 minute, there's 7. After 2 minutes, there's 14. After 3, there's 21. If you want to find a constant proportionality, k equals y over x. Pick any value, 4 and 28, 3 and 21, 2 and 14, doesn't matter which one. Plug it in. Let's use 2 and 14. 14 divided by 2. And the constant proportionality is 7. Does it work? Is every x value multiplied by 7 to get to the y value? Yes, it is. What does the point 2 and 14 represent? It represents that after 2 minutes, there are what, 14 gallons of water. That's what it represents. Okay. How can you use this point to determine the unit rate? Well, if you write the unit rate, then let's write it as a fraction. 14 gallons over what, 2 minutes? That is just a rate, right? The unit rate is just simplified to where the denominator is 1. How do I get that 14 over 2 as an equivalent ratio where it's over 1 minute? Well, I mean, in the 6th grade they tell you, right? What did you do? Divide 2 to get 1. Well, you divide that by 2. So therefore I divide the top by 2 and I get what? 7 gallons. And there's your unit rate. Right? Write an equation. So again, we know the constant proportionality. We have the unit rate. So this is all means that this is a proportional relationship. Because if it wasn't, we wouldn't have the unit rate or the constant proportionality. Okay. And then where are we? Write an equation to determine the amount of. Okay, there's something. The questions are. So let me just keep this as this. Just write an equation. Let's cross all that out. So the equation obviously is y equals 7x. Explain what your equation is saying. The equation is saying that the total number of gallons is equal to 7 times the number of minutes. Check your work. Well, you can do y equals 7x. You can pick a point, any point on the graph. You You can go back to the table, check your constant proportionality. Okay, you can pick a point and substitute over here. Let's say 2 and 14. Let's just use the same point. Plug it in. Y is 14. 7 equals 14 equals 7 times 2. Moving on. I don't know what happened to the question. 5. The table below represents the price of what? The price for different quantities of apples at a store. So 5 apples, $2. 10 apples, 4. 15, 6, 8, and 20. Write an equation that represents relationships. Blah blah. What is the constant proportionality? What's the unit rate? Well, let's find it out. So K, proportionality, is y over x. Price is my y. Apples is going to be my x, right? The price that you pay, right, at the register depends on the number of apples. That makes sense, right? Which makes my price the y, or the apples, and the apples the x. This is my output, or input. This is also known as your dependent. This is called your independent value. All right, so let's pick a value. Let's do the first one, 5 over 2. So K equals 5 over 2. That means that every apple, right, is 2.50. So just knowing this, I know that every apple is $2.50, which says that the unit rate, and I'm answering the second question, is $2.50. One apple, let me write that with the appropriate units. So let's see if this is proportional. So that means that if I multiply this by 250, I get 5, that's right. If I multiply this by 250, I get 10, that's right. Times 250, do I get 15? Yes. Times 250, do I get 8 times 250, do I get 10? Yeah. So what is the constant proportionality? 2.5. What is the unit price? $2.50 for one apple. I need the units there. What's your equation? Y equals 2.5x. What's your equation saying? And I'm not going to write it again. So it says here, price depends on, the price that you pay is equal, the price is equal to 250 times the number of apples. All right, so that's if it's proportional. Using your equation, determine the price if you purchase 30 apples. Well, here's my equation, y equals 2.5x, right? I want to know the total. The total is going to be 2.5 times how many apples? 30. And if you multiply that, you get 75. So y, the total that I pay at the register, is going to be $75. All right. Okay, looks like that. Oh, they're all proportional. Jeez. Let me do 6. Why 6 sounds repetitive? Again, 6. We can do 6. We have, so when x is 8, let me write the table. When x is 8, y is 12. You want to know when x is 30, what is this value? Well, when you find that relationship, right? Proportional. If it's proportional, can you find a relationship? Hey, you can find a relationship here if you wanted to. What times 8 equals 30? You would have multiplied that by the same way. But since we're using constant proportionality, let's keep that. So K, the constant proportionality, right? The number that I multiply 8 times, the number I multiply x by to get to y. Well, let's use this. So K is y over x. In this case, K equals 12 over 8. And K equals, and we're going to leave it as a fraction, okay? Let's simplify by 4. We're going to get 3 over 2. So K, our constant proportionality, is 3 over 2. Now, well, let's just, what do you call, test it out. So 8, so when x is 8, y is 12. Let's see if that's true. So when x is 8, and if I multiply that by 3 over 2, do I get 12? Well, 8 and 2 can be simplified, and then 4 times 3 is 12. Look at that. So that is true. So then, therefore, the 30 over here to get my y value, right, my output. So my input is 30. So think about it, and I remember this a long time ago. So think about it. Here is your input, right, which is your x values. They're coming in here. And what's happening here? Well, in here, it's being multiplied by 3 over 2, and out comes your output. Right. So what's coming in here in this time? Well, the number that's coming in is 30. So the input, if you put 30 in this, right, in this machine, in this box, well, every number, every x value that comes in is going to be multiplied by 3 over 2, and then you're going to get your output. So 30 times 3 over 2 is, what is that, 45? Sorry, yeah, 45. All right, so when x is 30, y is 45. Alexa, stop. 7. What's a constant proportionality? All right, so again, I don't know if you want to do this, but maybe tables help. All right, so again, time is my x. How do I know that? Because it's in the x-axis, and this is the distance. So the distance that you travel depends on your time. Makes sense. I'm going to put some points that I recognize, or actually that I can actually figure out the value. So when x is 5, it looks like y, and what's between 8 and 4. So this, again, there's nothing wrong with you coming into the graph and filling. So 0, 2, 4, 6, 8, 10, 12, 14. Put the missing numbers there. So when x is 5, y is 6. I have that number. When x is 10, y is 12. When x is, what is this, 15, y is 18. So definitely proportional. Look at this. Doubles, doubles to go from here to here, triples, triples, right? They're equivalent ratios. So let's find a constant proportionality anyway, because they're asking us. Okay, what? So again, if you, I should have said this before. Here's your input, right? Your input, your x value. You're coming in here. You're putting the 5. You're putting the 10. You're putting the 15. You're putting these numbers in this machine, and then something's going to come out, which is your output. Out. So what is happening inside? Well, what's happening to 5 to get to 6? What's happening to 10 to get to 12 and 15 to 18? Constant proportionality, y over x. So let's pick 5 and 6. So if you use it between 5 and 6 to figure out your constant proportionality, you're going to do 6 over 5. That's it. So it's times 6 over 5. So every single number in here. So let's, if you multiply, let's say 5 times 6 over 5, well, you get 6. Multiply 10 times 6 over 5, look, you get 12. So this works for this, it works for this. So if you get 15, you put it in there, and then it's multiplying by 6 over 5, do you get 18? Well, that simplifies to 3, and 3 times 6 is 18. Yes, it does. So every single point in here is being multiplied by 6 over 5. So what's the constant proportionality? 6 over 5. What's your unit price? Well, if you know this, right, so that's also your unit rate. So your unit rate is, sorry, this is not unit price, should be your unit rate. It should be distance travel in how many hours? In 1 hour. And let's put that, so that's 5, that's 2.5, so 1 is about here. And you obviously can't tell what the y value is. So the y value, or your unit rate, is also, now that you know it's also your constant proportionality, it's 6 over 5. So you can say that the distance is 6 over 5 miles in 1 hour. Can we get the equation? Again, so knowing the constant proportionality, you know the constant proportionality, which also, you know the unit rate, which also, if it's proportional, now you know the equation. Every hour, this person hikes 6/5 of a mile. Okay? All right, so go over your notes for Monday's quiz.